So basically they often have to mention the control test. And controls for bear in mind, control test is going to be that test which will always give either a completely positive result or a completely negative result. What does that mean? That means that, for example, if I am doing a starch test and I know that I have a known starch solution and I'm adding iodine to it, I know what the positive result is supposed to be. Or it could even be that instead of using starch, I end up using water. So I'll definitely know what a negative result looks like, right? Similarly for control test or otherwise, if I want to, ensure that the pH has to remain constant. Let's say I need to standardize certain variables, standardize or make certain variables a bit constant, if you will, okay? So that comes to a different scenario. One thing is to say control test. So that's a different thing that I talked about. Then there's another thing to say that I need to standardize variables. I need to keep certain things constant. I need to control certain things. These are two different things I'm talking about. In the first scenario, I told you a control test. And control test will tell you what is going to be the scenario if it's going to be a positive result, what is going to be the scenario if it's a negative result. But a standardized variable scenario where you have to standardize the variables in an investigation or control the variables in an investigation or ensure that the variables remain constant, that is a scenario where you have to ensure that, for example, how did the pH remain constant in any particular solution? The best way to do that is to say that you're going to add a specific volume of buffer solution. What am I saying? A specific volume of buffer solution. Remember, buffer solution keeps the pH from going up and down. And what if I need to standardize temperature? For standardizing temperature, the pet words or terms that I use is to use a thermostatically controlled water bath, right? Thermostatically controlled water bath is what I'm going to use, right? So that's standardized variable for you over there as well. Take it. The conditions in which seeds and flowers grow, that can also be part of your syllabus. I'm basically looking at this over here. So for example, the conditions that are required for germination to take place, right? And the reasons behind that. So germination of seed obviously requires three things and three things only. And that is water, that is oxygen, and that is a particular temperature. So you can remember as hot, H for H2O, O for O2, and T for temperature. Right? And no fourth thing, right? The mineral ions are there once the roots come out. So not relevant, all right? Similarly, if you're talking about, light intensity or light for that matter, light is obviously for photosynthesis again. And that's when obviously the plumule comes out. So remember that it's going to be the scenario where it's going to be this way. Yeah. Words showing negative geotropism, and the roots will grow downwards showing positive geotropism or gravitropism for that matter. So keep that in mind as you move forward for those responses. Heart rate and breathing rate ke liye ek cheez zehn mein rakhega ke obviously I'm sure everybody knows what the impact of exercise is on heart rate. I'm pretty sure there's no issue, but how to measure heart rate is really important. So how to measure heart rate is basically to taking the pulse. For the pulse, you need to use your two fingers, other than the thumb, on the just on the wrist below the thumb, and count the number of times. That's one aspect of it. Or place the same fingers under the neck near the jugular vein. Or use a stethoscope on your chest to listen to the number of times the heart beats in a minute. That's what heart rate is. For breathing rate, again, we generally are not probably going to be asked, but generally what we use is something called the spirometer. All right. And in that sense, remember for breathing purposes, obviously the importance of intercostal muscles is going to be there. But, the way the graph sometimes looks like that, let's say this is the volume of air taken in. And let's say you've got this consistent crest and trough going around for you. These consistent crest and troughs are basically referred to as the tidal volume, the normal amount of, not supposed to say amount, I'm supposed to use the word volume, the normal volume of air inhaled and exhaled. So the crest is the inhaled portion and the trough is the exhaled portion, right? However, if let's say you get into exercise or somebody just scares you, then obviously your breath might go up a bit, which means that the volume of air you're taking in is greater. And the volume of air that you exhale out is also great for a little period of time. Now, what is this then? So this portion whereby you've done your maximum inhalation, followed by maximum exhalation, this essentially is referring to the concept of vital capacity, the capacity of your lungs to be able to inhale as well as exhale at its maximum. So that's basically what it is. And of course, even though you might have exhaled properly, is called residual volume. Okay, the amount of air left behind after complete exhalation is called residual volume. I don't expect that they'll ask you why the residual volume stays, but just for the sake of your general information, residual volume stays so that the lungs do not collapse due to extreme pressure changes. And the second thing is that you know that your alveolus is supposed to inflate and deflate, right? So if it deflates totally during an exhalation, it becomes really difficult for it to deflate again. So that's basically the scenario. Okay, so I'm concluding this quickly so that we can move forward to some more important things. The importance, of course, of drawing diagrams cannot be underemphasized. So I'm going to obviously do that by taking an example of it. But continuous, discontinuous variation. Remember, continuous variation are the ones in which are constantly changing. So that could be height, or that could be length, right, of leaf, or that could be number of stomata of the leaf. Things that do not have a discrete categorization and can be represented, by the way, by a curve, if you will, or it can be represented by a histogram. A histogram, remember, has no gaps in between its bars. For example, so discontinuous variation is when you have discrete specific categories, and the only way best that it can be represented is in the form of a bar graph. And remember that whenever you get asked to make a bar graph, the width of the bars as well as the width between the bars have to be the same all the time. They have to be equal all the time. So width of the bars should be specifically the same for each bar, and the width between the bars also need to be the same after each bar. All right, so that needs to be ascertained as well. Moving forward, then we also finally, if you can look at this final aspect, it says use methods of sampling that are represented in the word bias. Not a lot of questions have come here. Maybe some from 0610, but I hardly doubt many of these questions have come in 5090 before. So without going into too much detail, just remember that sometimes ecologists have a task of having to count the number of a particular organism. So they have to find out the abundance of a particular species, for example, in an area. Let's say it's a whole grassland, all right? So what are the two ways in which they can go about it? They can go about it either by random sampling. They either go about it by the random sampling, or they go about it by systematic sampling. Random sampling is mostly that, if at all, will be asked. Random sampling ka matlab hai ki it is without bias. What does without bias mean? Without bias means that you have a scenario where you're using something that you call, and I'm writing the name here, through an app maybe, or through a device called a random number generator. A random number generator is supposed to give you a specific number so that you can count at which particular specimen you have to take for the test. So for example, if you have divided your ground, for example, into 100 small squares, right? And you need to ensure that okay, so again, these are, let's say, 100 small squares. Each of them, let's say, being 1 meter by 1 meter in their length. So what you need to do is you need to ensure that you don't choose the first one, then the 5th one, then the 10th one, then the 15th one. So this becomes a pattern. And why are you choosing this? Because maybe you get asked that what are the number of, let's say, a number of jasmine flowers in this particular garden. So if you start to have a method, 1, 5th, 10th, and 15th, if you start to have a pattern, that's systematic sampling. But if you start choosing randomly, so let's say you choose the first one, then you choose the 11th one, then you choose the, the 33rd, then you choose the 49th, so on and so forth. That means that you're doing random sampling. So again, if any questions like that happen, just remember random sampling is that you are trying to choose specific areas of the grassland or specific areas of that particular place or that particular ecosystem where you are taking a look at what you need to do. Okay, so this is basically regarding it. Now, for some discussion related to the do's and don'ts. And then, of course, we will virtually get to the conclusion by looking at some questions. So when you are looking at the do's and don'ts, again, some of them are very clear to you already, I hope, but just bear with me as this opens up. And during this time, by the way, if there's any question that anybody has regarding what part of the syllabus that they believe could, come, or you can ask if it can come, and you can let me know. So yeah, regarding the ATP paper, wherever you are, the assessment objective 3 is coming into play. Assessment objective 3 is experimental skills and investigation, as everybody knows. Okay. Now, what does that mean? That means that you need to be able to follow a set of instructions. Now, tomorrow when you're going to go for your exam, here's the thing. When you're going to go for your exam, one of the biggest challenges that you face, possibly, is that your exam will be extremely wordy. What do I mean by wordy? It probably will have a So इसमें कुछ शक नहीं है कि everybody is gonna feel that, but then again, if you have been someone who's been practicing, then you probably will have gotten the hang of the scenario that this is normal. In fact, I'm here to tell you right now, it is actually preferable that it is a long length. Now, it might sound a bit weird saying it, कि ये ज़्यादा length है. इसको इस हिसाब से देखें. What if I tell you that you have, for example, you have to do an investigation where you're looking at the effect, for example, of temperature on, on rate of photosynthesis, for example, right? And I just tell you this, and then I tell you, okay, tell me the variables that should be constant / standardized, right? Now, if I stop my, if I stop my, what can you say, my question right here, then you'll have to speak of a lot of things that are standardized during the process, isn't it? I mean, you're going to say that, okay, I'm going to have to ensure that the light intensity doesn't differ. So the lamp has to be placed at a particular distance, can be more or less. I have to ensure that the carbon dioxide concentration has to be absolutely on the key, which basically means that my source of carbon dioxide, which is sodium bicarbonate, has to be absolutely fine as well. I have to ensure that every time I use the same plant. So again, I'm actually, the bonus mostly is on me now as the candidate to write the answer. But what if I tell you that, okay, what if they give you the same question, but this whole thing becomes part of the question, the one that I've written down, that they're asking you the effect of temperature and rate of photosynthesis, okay? And they end up asking that the constant variables include the light intensity, and they tell you how the light intensity is constant. They tell you the carbon dioxide concentration is constant. They also tell you it's the same plant, for example, all right? Then they ask you, for example, that what other variable should be constant? You understand? So now it becomes a close-ended answer, doesn't it? So it actually matters कि आपको ज़्यादा जब मिलेंगे instructions, तो आपका थोड़ा जो answer ना narrow-ended हो जाएगा, which actually works for you. Now,